So in this video, we will look upon some standard integrals like trigonometric integrals and some particular integrals as well, and we will proceed to do some problems applying the what we learned. So the first is the integral of tan x dx, and that is equal to log sec x plus c. So how do we proceed? How do we derive the integral of tan x dx equal to log sec x plus c? So let's simplify the integral tan x dx. That is sin x by cos x dx. Now we can integrate this function, this integral by integration by substitution. Just put cos x equal to t. That will give minus sin x equal to dt by dx, which should imply dx equal to dt by minus sin x. Therefore, the integral of tan x dx will become integration of sin x by t. Now, in place of dx, we can write dt by minus sin x. So we can cancel the sin x. So minus of integral of dt by t, that we know, minus of log t, which is log minus log of cos x plus the arbitrary constant c in order to represent the family of functions this integral represent. So we can write minus log cos x as log cos x raised to minus 1. That is log 1 by cos x, which is log sec x. So integral of tan x dx is equal to log sec x plus c. So now we will compute the derivative of sec x dx, that is equal to log sec x plus tan x plus c. So how do we proceed? We can multiply the function this integral by sec x plus tan x by sec x plus tan x, that is sec x into sec x plus tan x divided by sec x plus tan x. So we are essentially multiplying this function by 1, so it doesn't change the function. Now we can proceed by integration by substitution. Just put sec x plus tan x equal to t. That will give us the derivative of sec x equal to sec x tan x, and the derivative of tan x is sec square x. So the derivative of this term will become sec x tan x plus sec square x equal to dt by dx. So dx becomes dt by sec x. Just take outside the sec x. So tan x plus sec x we will get. Now, put this back into this formula of sec x into sec x plus tan x by sec x plus tan x. So we can compute the derivative, that is sec x into sec x plus tan x divided by, we substitute this term for t, so we put t here, and instead of dx we can put dt by sec x into sec x plus tan x. So this time cancel and this time cancel, will essentially become dt by t, which is log t plus the arbitrary constant. So integration of sec x will become log, and substitute back the term for the t, that is sec x plus tan x plus the arbitrary constant. So now we can calculate the integral of cosec x dx. For this, we will proceed by multiplying this function by cosec x minus cot x by cosec x minus cot x, which is essentially 1. So cosec x dx. We multiply this function by cosec x minus cot x divided by cosec x minus cot x dx. Then we proceed by integration by substitution. So we can put cosec x minus cot x equal to t. That will give, we know the derivative of cosec x. Cosec x is minus cosec x cot x, and the derivative of cot x equal to minus cosec square x. So this will become cosec square x equal to dt by dx. So dx will become dt by, that will give us cosec x into cosec x minus cot x. So we can substitute this back into our integral. So we will get cosec x into cosec x minus cot x by t, and dx, we can replace dx by dt by cosec x into cosec x minus cot x. So we can cancel this term, this both term. So this will essentially become dt by t, which is log t plus c. Now we substitute back log cosec x minus cot x plus c. Or in an alternative way, we can proceed by multiplying this function cosec x dx by cosec x plus cot x by cosec x plus cot x. That is cosec x into cosec x plus cot x divided by cosec x plus cot x dx. So we can substitute this cosec x plus cot x equal to t. That will give the derivative as minus cosec x cot x minus cosec square x equal to dt by dx. That will give dx equal to dt by minus cosec x into cosec x plus cot x. So our integral will become like integral of cosec x into cosec x plus cot x by t. Instead of dx, we will replace by dt by minus of cosec x into cosec x plus cot x. So we can just cancel these terms. Now our integral become dt by t, which is log minus of log t plus c. So this minus log t becomes minus log cosec x plus cot x plus c. And how will we get this cosec x plus cot x? We can replace this term by cosec square x minus cot square x by cosec x minus cot x. Since we know sine square x plus cos square x equal to 1, this would imply if we divide these terms by sine square x, we will get 1 plus cos square x by sine square x, that is cot square x equal to cosec square x. This will give cosec square x minus cot square x equal to 1. So cosec x plus cot x can be written as 1 by cosec x minus cot x. So minus of log cosec x plus cot x can be written as minus of log 1 by cosec x plus cot x. That will that will, like, if we put this minus as a power here, then it will become log cosec x minus cot x. Sorry, here it is minus. So the integral of cosec x dx can be alternatively find out by this method as log cosec x minus cot x plus c. Now we can find the integral of this particular function 1 by x square minus a square. So how to proceed? We can simplify this function 1 by x square minus a square as 1 by x minus a into x plus a. This can be further reduced to some simpler expression if you can, like, put in the denominator x plus a minus x minus a by x minus a into x plus a. But here we will get 2a, but actually the numerator is 1. So we had to multiply this whole term or divide this term by 2a. So by further simplifying this, we will get x plus a by x minus a into x plus a minus x minus a into x minus a by x minus a into x plus a, and reducing this and simplifying this, we will get x plus a by x minus a, so not x plus a, which is actually 1, minus 1 by x plus a. So this integral is reduced to the similar expression. Now we can integrate integral of dx x square minus a square equal to integration of 1 by 2, take it outside, and 1 by x minus a minus 1 by x plus a, so dx, and the integral of this will be 1 by 2a, integral of first the integral of 1 by x minus a, which is log x minus a, and the integral of 1 by x plus a, which is log x plus a, and this can be reduced to we had to put the arbitrary constant. This can be reduced to 1 by 2a log x minus a by x plus a.